is not same like how it is in the other simulation tools, because as we are into same interface, we need not get adapt to a new interface. And one more strongest advantage is the way the SolidWorks flow simulation solution has been designed is it can be easily understood by a design engineer. So the terminologies used are not complex, and they can be easily understood by any design engineer, and it involves only a very short or a quick learning curve. Okay. We are saying like why SolidWorks flow simulation has to be used. Now let's see in what applications it can be used, in which industries it can be used. It can be, of course, it can be used for HVAC when it comes to room ventilation, or when it comes to comfort parameters, which we will be discussing in detail in the upcoming slides. Apart from it, the same solution, SolidWorks flow simulation, can be used to address the needs of electronics industry, automobile industries, aerospace domain, and into valve industry. So these are few areas which have been highlighted, but it has its extended capabilities to address the needs of other industries as well. These gives an idea of what will be achieved at the end of this webinar. So as an attender, I'll be aware of what SolidWorks flow simulation HVAC module is, what it is capable of, in where I can implement this, what are the industries I can use it for, and how I can use it. So all these parameters, all these things can be achieved by end of this webinar. Where this HVAC module can be used. Again, HVAC stands for heat ventilation and air conditioning. Where it can be used, it can be used to see the effectiveness of the ventilation system in a room or in any internal space or occupant environment. For example, it could be used in the classroom as the image shown on the right corner to see the airflow optimization. It can be used in an office environment, which serves for the benefit of employees' comfort. It can be used to study the ventilation system effectiveness in a large stadium, or it could be a parking garage where we can use this HVAC application to study the smoke ventilation, how effectively I can vent the smoke out of the garage so that it may not lead to suffocation for the persons using it. When we say visualization of flow fields, it is how effectively my flow penetrates or uses the occupant space, whether the flow field is in all, it's distributed equally in the entire office region or a classroom, or is there any region where there is not much of a flow exists, and whether it has to be taken into account. When we are speaking about the effectiveness of the ventilation system, it is basically how can I design my ventilation system which can effectively fulfill the requirement. When we say requirement, it could be energy requirement, or it could be with respect to where to place the ducts and what type of fan selection has to be there. As we are in this, I'd like to give a real-time example. You'll be familiar with BIA, Bangalore International Airport Cargo Complex, where smoke studies has been done with the help of CFD code to determine how effectively the smoke can be vented from it. That is, in an event of a smoke breakdown, how effectively can it be vented out of it, so it may not lead to an discomfort, and also it leads to the safety of the occupants and the employees in the cargo complex. How it is achieved and what are the parameters achieved are where exactly the ducts has to be placed and what type of specification has to be used, what are the quantities has to be maintained. So all these parameters are analyzed for the Bangalore International Airport cargo complex with the help of the CFD codes. So this is one example of a real-time application. So is this HVAC module can be used only for the internal application? No, it can also be used to study the effect on the external environment as well. As the picture shows, the right bottom, it shows the huge blocks and the streets. Another real-time example would be, which I'd like to narrate is, the CFD codes are used to study the canoeing effect. Canoeing effect is how comfortable the citizens are when they are using the pedestrian cross. Similar study has been done with the help of CFD codes in Manhattan Financial District, US, to determine the comfort level of the citizens or the passengers who are using the pedestrian cross, because as we know, the real-time conditions would be huge blocks surrounded and in between narrow pedestrian crosses would exist. So with the help of the CFD codes, they determine the comfort level, and also which as an advanced cases which can lead to whether in future if any buildings has to be constructed, with the help of the CFD code, they determine whether it will have any impact on reducing the comfort level of the citizens who use the pedestrian cross. So that's one real-time example. Apart from internal applications and external applications, the other things like other advanced parameters like free convection or forced convection, say natural convection. Even there are several buildings residential buildings has been constructed in regions like Calcutta, where high temperature and humidity exists. Until date, there were no requirement of using an air conditioning or adding an air conditioning to their residential place, because it has been constructed in such a way with the help of CFD by using natural convection, how efficiently my design can be, so that much of outside atmosphere interacts with the inside. That is, much of an ventilation is provided, so that very high temperature or suffocation is not existing in the residential place. It can also be used to study the smoke modeling. That is, if there is in a case of event of smoke, how it can be vented out. So as we discussed before, with the help of the cargo complex of the international airport, so that not only leads to the safety of the employees, but also it gives an confidence on the design. It can also be used to study the parameters in hospital. Okay, when we say hospital or a clinical rooms, what are the parameters it could be? Let's consider an hospital operation room. What would be the real scenario? One vulnerable patient surrounded by 3 or 4 surgeons operating on. So what are the parameters which can account for, or how this HVAC application has a very importance over there? Let's take an example. We all are familiar with Boeing 747 aircraft, which can carry more than 300 passengers. Consider, for an example, like among in a week, 5 of that Boeing 747 aircraft crashes with a zero survival rate, and it continues throughout an year. Imagine the casualty, it would be approximately 1 lakh. Similar kind of casualty is reported from POI, post-operative infections. That is not due to the operation failure, but it is due to the contamination existing in the hospital environment or the operation room environment. US-based HVAC company came up with a study, and they have determined it is approximately 1 lakh per year. The casualties are due to this post-operative infections. So, how the HVAC module can be used in reducing the contamination level in an operation room or an hospital environment or in clinical labs. So, it can lead to orientation of the flow in a pattern such that not much of a recirculation zone exists, so that the contaminations are properly vented out of the occupant zone, and it does not lead to the post-operative infections. So these we can see in the upcoming demonstration. On top of it, we can also use this HVAC application to study the comfort level of the occupants. In this case, the comfort level of the patient and the attendees, and the attender who is addressing the patient in the clinical rooms. This is a demonstration of the hospital environment. This is an hospital environment with a transparent property, so the what's happening inside is visible to naked eyes. So this is an hospital room where there is a patient lying on the bed and then a caretaker standing nearby the patient. So here, how HVAC application or the SolidWorks flow simulation HVAC module can be used to study the effectiveness of the ventilation system. So here, all the real-time parameters are considered, like heat generated from the ceiling lights, from the TV equipment, from the hospital equipment, on top of it, from the patient and the caretaker. As we know, humans are the constant heat generating source. So all these real-time parameters are provided to study the effectiveness of the ventilation system with the help of SolidWorks flow simulation. So this plot shows the comfort level of the patient who's lying in the bed. So when we speak of comfort level, it has been predicted with the help of 7-point thermal sensation scale, which ranges from 0 to +3 and 0 to -3. This scale has been designed based on the ASHRAE standards, and it is used, or it is included in the SolidWorks flow simulation module. So what we can predict from the scale? How comfortable the humans are, in this case the patient and the caretaker, and also how comfortable the environment is for the designed ventilation system. So here the top region shows a red contour which is around 0.7. In the scale of -3, 0 to +3, between 0 is the neutral region and plus and -1 are allowable zones. So here we can see a range of 0.77, so which implies it is still in the acceptable zone. So similarly, the comfort level for the caretaker can also be seen studied. So here the bottom region gives an value of 0.4, which predicts that it is the caretaker feels a warmer zone in the bottom of the room. But as I said before, the zones between +1 and -1 are the acceptable zones, and the design of ventilation system in this scenario is an effective system, and when it comes to a comfort level, as it lies in the well acceptable zones. Similarly, airflow can be studied within my model to account for the effectiveness of my ventilation system design. Here these blue lines and the light blue color line represents the airflow movement within my occupant space. So with the help of this, I can study how effectively my ventilation design is, whether each regions of the rooms are properly circulated with air, or if there is any return zones or recirculation exists. So this is an animation of airflow movement. So with the help of these, I can optimize my design to study the airflow, whether if there is any recirculation zones which can be accounted for. On top of it, I can also do an optimization to come up with one unique best design for my ventilation, occupant zone ventilation. So SolidWorks flow simulation gives us a provision to run n number of designs so that we can come up with an optimized solution. Is it only used for internal studies, external studies like vent loading and clinical rooms to study the comfort level? No, it cannot. It also extends its capabilities, like it can it can address the requirements of the LED industry as well. As we are speaking about LED, I would like to mention a transformation. A few years back, we were using the incandescent light. Later, we shifted to CFL lights, and now it is an era of LED lights. When we are speaking about why this transformation, compared to LED, the other two radiates the IR and the UV. When it comes to LED, it radiates very less or no radiation of infrared and the ultraviolet lights. But the drawback is the amount of heat emitted from the LED is very large, so a very careful or optimized heat sink design has to be done so that these heat can be vented out for the life cycle, very high life cycle of the LED lights. So with the help of this HVAC module, it can address the requirement of LED industry in designing and optimizing the very powerful heat sink, which ultimately leads to the very large life cycle of the product and accounts for the benefit of the manufacturer, and it's a cost-effective solution. It can SolidWorks flow simulation, this HVAC module can also address the requirement of contamination level which exists in a natural in the outside environment or in industry specific applications also. When we are speaking about contamination, so it is the mixture, or we can say admixture or a tracer in the existing carrier fluid. The carrier fluid could be an air, and it depends on the applications which we use. In general, the carrier fluid could be an air, and how much amount of contamination exist in my environment can be studied with the help of this HVAC module. It is given with the help of two parameters. One is local air quality index to study the effectiveness of my ventilation system in removing the contaminant from a point or from a region where I am interested in. And the other parameter through which I can study the effectiveness of my ventilation system design is given by CRE, contaminant removal effectiveness, with the help of which I can judge whether my ventilation system is effective enough to remove the contamination from the old space or from the occupant space or the environment. This is an example of a white light comparison where this HVAC module can be used to study which is the better design and from which the amount of radiation emitted is well within the acceptable zone. So this HVAC module can also be used to study the effectiveness of my ventilation system when it comes to heating systems. If there are very large heating systems exist, or if it is a very limited heating system, I can design my ventilation system based on it so that the amount of heat generated is completely removed with the help of an unique optimized ventilation design, so that the heat does not penetrate inside the occupant space, which might lead to discomfort and increased in energy utilization, and ultimately it leads to very high energy bills when it comes to energy consumption. So is it stops only with it? No. It also leads to a negative impact on our environment with consuming more of its materials. So another great advantage with this SolidWorks HVAC module would be its very large material database, extended material database. When it comes to ventilation system design or the diffuser design, and the type or the specification of fan used can also be studied with the help of this module because of its extended material database capabilities. So readily I can select a fan and directly use it for a simulation. I need not model a fan, so the time I would be investing in modeling a fan and giving the parameters, obtaining the parameters from a manufacturer is a complex task, as we know. So with the help of this extended material database, we can directly pick a fan and readily use it into the simulation environment. The biggest strength of this material library is it comes with all the database when it comes with a fan curve or SN curve. So all these comes directly included in the material library. So this is a demonstration of an office environment with an occupant working in a space, and here objective is to study the comfort level and the temperature zone, if there is an radiation exists or if there is no radiation, or in case if a shielding is used in the windows. So ultimately all these leads to the judgment of effectiveness of my ventilation system, how effectively my design is. This is an office environment with the door kept open, and the top opening is the airflow inlet, and these windows are faced by the occupant or the region of study where different cases are studied. In this case, 3 different type of simulation has been performed for this model to determine the impact of solar radiation inside my occupant space. First scenario has been done without solar radiation, the second with solar radiation, and the third if there is a shielding used, and what is the impact when it comes to temperature penetrated inside my occupant zone and how comfortable my occupant zone is. This gives a temperature plot if there is no radiation exists. So you can see the outside zone, yeah, is in the well in the range of 30, and the inside is in the range of 19 to 20. This is without solar radiation. Let's see with including the solar radiation into my occupant space, how the temperature distributions would be. So now the outside environment is in the region of 33 and the inside is well in the region of 25, across 25. So with the help of these, I can come up with a better ventilation, better HVAC design so that it accounts for all these different types of scenarios. Now let's see how the temperature distribution is if radiation shielding has been used. Now the temperature zones are, temperature zone varies. It is well within 30 outside and it is around 22 inside. So the another great advantage of this flow simulation module is it has the inbuilt properties of solar radiation as well. When it comes to emissivity of the material, how effectively it can radiate the heat, and the radiation parameters are all included in this module, and it is easy to use. So I have to define my material properties within my environment, and I have to mention whether if there is any solar radiation is analyzed for this, or I can also define if there is any shielding, and I can study for all these parameters to see or to come up with a better stage to see like how effectively my ventilation system design can be. So all these what we are talking are like solar radiation, comfort level, temperature distribution, all these are can be performed right at the day one at the design stage. So the biggest strength is biggest strength of SolidWorks is its tight CAD integration. So right at the design stage, I can perform the simulation to come up with a optimized HVAC design. This is a customer success story. Yeah, this is a customer success story of our French customer, Dome Space International. They are into building construction. So they are into construction of world-class spherical shaped buildings where it can not only account for structural strength when it comes to earthquakes and seismic, but also it can provide an efficient comfort zone and ventilation system designed for the model. They have constructed a world-class spherical shape design which is also rotating on the outside so that it can follow the sun during the winter and sun's shadow during the summer. So ultimately what happens is it accounts for the energy consumption, which is not only towards eco-friendly environment but also very big or a drastic drop in the energy bills. And now to summarize, summarize, we have seen like why these comfort parameters has to be used, how the HVAC module can be used to study comfort parameter, the radiation and library and the contamination zone. So it is inbuilt material library and contamination zone. To what industries it can be used? It can serve for lighting industry, HVAC, for facades, what type of material I have to use for contamination studies, hospital environments, and we have seen the demonstration of the hospital rooms, how it can account for, how the effective ventilation system can account for the comfort level and in an office environment. Now let's proceed to the Q&A session. So you can see a chat window on the right side and you can write your questions onto it. Please use the chat window to clarify any doubts which you have. Yeah. Okay. Okay, we have one interesting question. Okay, how this will be useful for electronic industry? Uh, as it is not very much related to today's agenda, I'll give a brief idea on it. So with SolidWorks flow simulation, it has its strongest capabilities of electronics module, which can address the requirement or address the needs of electronics industry. When we're speaking about electronics industries, the ultimate objective would be the very high temperature zones, how to cool and optimize my design, electronic design. See, there are situations in reality where market leaders like Sony who are into PlayStations have replaced all their equipment due to the failure because of overheating. That is not providing a proper or optimized heat sink. So imagine a cost if they want to replace globally all the failed systems. So that's an example. So similarly in electronics industries, the SolidWorks flow simulation module can be used to study the effectiveness of my effectiveness and optimization of my electronics cooling. So when I'll get back to you in brief details about it later. There's another question: can we do this simulation and digital manufacturing tool? Can you please be more elaborate on this question? Like what type of manufacturing tools you are looking for to do simulation? Yeah, that's another question. We need motion analysis, simulation, demo, or training. Okay, we'll get back to you on this regards. And one more question. What is the PMV values shown in the cut plots? PMV stands for predicted mean vote. It is a 7-point thermal sensation scale designed based on the ASHRAE standards to predict the comfort level of the occupant inside the occupant zone. We'll get back to you on this regard, as the agenda for today's session is more on HVAC. So kindly use the chat window for more information on these HVAC simulation. There's another interesting question. Will it give exact values as some other simulation techniques? That is, can it be considered as a final one? Yes, it can be considered as a final one because we have several documents which has been validated with the real-time conditions, and we can share it to you. There's another question: how to make electrical layout and circuit diagram? As it's more into electronics, and today's agenda is focused on HVAC. We will get back to you in the later regarding this. There's another question: how to make simulation and motion? Can you please be more elaborated in this regard? What exactly you want to simulate and to do motion analysis? The another question is, how much will this be useful for electronics industry? So the SolidWorks flow simulation as its strongest, one of the strongest capabilities towards electronics industry, like how it is for HVAC industry. So as that is also not completely towards today's agenda, but we can get back to you in the later regarding this. Can you use the chat window if you have any questions regarding the HVAC module on SolidWorks flow simulation HVAC module? The Q&A session will be active for next 5 minutes. So kindly use the chat window. There's another interesting question: how to make a motion study with simulation in machine assembly, and how to find the deflections. There is an upcoming event on a machine tool industry. We will discuss in elaborated manner in that session. But still, if you want it before that, we can get back to you in this regard. There's another question. Can I discuss on inspection genie with example? Again, we will get back to you on this regard. Please kindly use the chat window if you have more queries on the HVAC module or how it can be utilized for your ventilation system effectiveness. Okay, there's another interesting question. How can I determine the ROI? Okay, ROI is a return of investment. So I guess what they mean is like using the SolidWorks flow simulation, how ROI can be achieved. So as we are speaking about major capabilities of this SolidWorks is tight integration. So the simulation which are performed are done right at day one at a design stage itself. So any changes made are performed right at day one and later changes are completely avoided. And it not only accounts for the internal condition but also external environment can be simulated. So what it means is it is a complete real-time scenario, how it exactly behaves in reality. So with the help of a design and with the help of simulating it in reality and short learning curve, all these accounts for return of investment. There's another important, interesting question. How this how this HVAC module can be used to study the comfort level of the occupant in different environments. As we discussed before, this HVAC module can be used to study not only the comfort level of the employees inside an office environment, but also it can be used to study how comfortable the students are inside the classroom environment, inside an industry where hazardous gases exist. And also, it can be used to study the cases where in an event of fire breakdown, so how the smokes can be vented. There's one more interesting question. How can I come up with a better or a unique HVAC system? So with the help of this HVAC module, we can optimize our design. So to come up with one unique solution based on the environment where it has been designed. That is like right at day one at a design stage, I can come up with n number of different designs, and with the help of the HVAC module, it allows me to optimize to one particular design where all my goals can be achieved. When I say goal, it could be a comfort parameter, or it could be energy consumption, or it could be airflow optimization. So all these can be addressed right at day one. We'll get back to you on the remaining queries. Uh, Thank you for attending this session. Thanks for your time. Also, we will mail this recorded version of the webinar. Thank you. Have a great day.